You may have heard the stereotype that only people of European descent have the ability to digest lactose from the time that they're born all the way into adulthood, and that minorities, including Black people, have been cursed with all the bloating, gas, and diarrhea that often come with lactose intolerance. We can still enjoy cheese pizza, but not without paying for it with unpleasant consequences. But is that really true? Is there really evidence that the ability to digest lactose from milk past infancy without any issues only evolved in one region of the world? If so, that would imply that people of African descent did not evolve to drink milk as adults, and therefore probably shouldn't even bother drinking it. I mean, why bother including something in your diet that your ancestors left out? In today's video, I'm going to explore the science of lactose intolerance, with a special emphasis on people from the African continent. I will discuss how tolerance for lactose actually evolved in both Europe and Africa, completely independently, and why only some groups of people across the globe evolved a tolerance for lactose while others did not. Understanding the phenomenon of lactose tolerance is going to take us through the fields of genetics, anthropology, archaeology, and evolution. I can guarantee that after you have finished watching this video, you're going to walk away with new knowledge and new perspectives. And make sure that you watch until the end as well, because that is where I'm going to talk about what to do if you are actually lactose intolerant. I'll be answering questions such as, if you don't consume dairy, what nutritional benefits might you be missing out on? And is there a way to get your body to tolerate dairy better? Here's a hint. There are actually several ways to get your body to tolerate dairy products, or rather lactose, more easily, even if you don't have the genetics for it. So stay tuned until the end for my tips. Now, as always, let's start with a little background. What is lactose intolerance? Lactose is a type of sugar found in dairy products. When a person has issues digesting that sugar and experiences abdominal pain, bloating, gas, constipation, and/or diarrhea as a result, they are said to have lactose intolerance. The reason why these people cannot digest lactose is because they lack sufficient quantities of a specific enzyme or protein that is needed to break it down. That enzyme is named lactase fluorescent hydrolase, or simply lactase. Now, in a person that can tolerate lactose just fine, lactase production in the small intestine breaks down lactose into smaller sugars, namely glucose and galactose. These sugars can be absorbed into the bloodstream easily. In someone with lactose intolerance, however, lactose passes through the small intestine into the large intestine undigested. And this is where the consequences take place. The large intestine is home to trillions of bacteria, and some of these bacteria take the undigested lactose and ferment it, causing gas and other familiar side effects of lactose intolerance. Side note, fermentation describes the process by which bacteria break down sugar in order to use it for energy without the use of oxygen. Now, while we typically refer to lactose intolerance as a single thing, there are actually 3 different types of lactose intolerance: primary, secondary, and congenital. Primary lactase deficiency occurs when the body just doesn't produce enough lactase. This usually happens in adulthood, and this is the type that I'll be focusing on in today's video. Secondary lactase deficiency takes place when the small intestine gets damaged somehow. Remember, lactase is made in the small intestine. So if the small intestine gets damaged, then the body also loses its ability to make lactase. This damage to the small intestine can result from diseases, infections, or physical injuries. The last and third type is congenital lactase deficiency. Congenital is used to describe any condition that is present at birth. This type of lactase deficiency is due to a rare genetic disorder. Now, while the focus of this video is lactose intolerance among people of African descent, it is important to recognize that lactose intolerance is actually very common among people both within and outside of the African continent. It has been estimated that close to 70% of adults around the world are lactose intolerant, with the highest rates of lactose intolerance being found in people of Asian, South American, and African descent. Now, let's get into the science. To get a clearer sense of how genetics can impact a person's ability to digest lactose or dairy products, we need to talk about the lactase gene. The lactase gene is what allows the body to produce lactase, that enzyme that breaks down lactose, the sugar found in milk. Generally speaking, some genes can be like burners on a stove. They are operated by dials that can turn them on or off or cause them to function at different intermediate levels too. Warm, very warm, kind of hot, very hot, you get the idea. This is also the case for the lactase gene. As babies, most of us have that dial turned all the way up so that we can consume the milk of our mothers and gain the innumerable benefits of it without any difficulty. After a baby is weaned, much less lactase gets produced. The flame on the stove gets turned down to less than 10% of what it once was past age 5. Now, some people have a dial that allows them to keep that metaphorical flame turned all the way up, and they can enjoy lovely dairy products as much as they want, while other people have a dial that keeps that flame just, on low, so they get a little bit of help digesting lactose or dairy products, but not that much, so they have to be more cautious. The latter group, of course, would be people with lactose intolerance. Despite the fact that we have known for a very long time that some people tolerate lactose better than others, it was not until 2002 that scientists were first able to pinpoint the genetic reasons for this difference. That is when the first genes that give people lactose tolerance were sequenced. There are actually 23 known types of genetic enhancers that have been identified around the world so far. Only 6 of these variants have been well researched, and about half are rare variants. These are actually examples of genetic mutations. These changes came about during the DNA replication process when cells divided and each became one half of a new human being. These genetic mutations are actually passed on in gametes, which would be your sperm and egg cells, and that is how they get passed from one generation to the next. Genetic mutations can be harmless and go unnoticed, while others can be harmful and cause life-threatening conditions such as sickle cell anemia and cystic fibrosis, while others still can be advantageous. These genetic mutations were clearly in the third category because they gave people the advantage of being able to enjoy the benefits of an easily accessible source of nutrition that their lactose intolerant peers could not. Now, when a certain genetic mutation is advantageous, it means that it makes it easier for someone to survive in a particular environment. And logic dictates that this person would therefore have an easier time surviving and producing more offspring. This was true not just in Europe, but also in Africa. Europe has the highest prevalence of people with lactose tolerance, with 90% of people in Sweden and Denmark having lactase persistence. Lactase persistence just means that their bodies continue to produce lactase well into adulthood, thus giving them lactose tolerance. The data points to Europe being the region of the world that is home to one of the oldest, if not the oldest, genes for lactose tolerance. There, the genetic ability to digest lactose well into adulthood is thought to have emerged somewhere between 5,000 to 12,300 years ago. Now, like I said earlier, DNA evidence also points to the evolution of lactose tolerance in Africa. What makes this really interesting is that this ability comes from completely different genetic mutations than the ones that were discovered in Europe. As I said earlier, there are over 20 different genetic mutations that allow for lactose tolerance. Several of those evolved in Africa. This is actually a classic example of convergent evolution. Now, you probably did not click on this video expecting to get an explanation about the different types of evolution, but hopefully you're enjoying this ride so far. If you are, don't forget to give this video a thumbs up and subscribe and leave a comment as well. Now, what is convergent evolution? To understand this term, we'll need to just quickly define evolution first. Basically, evolution is the process by which the frequency with which certain genes appear in a population changes due to environmental pressures and random chance. It occurs across time and as a result of the need for living beings to survive and adapt to their environments. When two different groups of living beings evolve the same ability independent of one another, this is called convergent evolution. It means that they converged or came to the same evolutionary principle, but that it happens completely separately without one influencing the other. Now, in the context of lactose tolerance, several populations around the globe developed this ability independently because they were in environments that favored being able to consume dairy throughout the lifespan. Other examples of convergent evolution that you might already be familiar with include the ability to fly in bats and birds. One has skin flaps and the other has feathered wings, but they both do the same thing, fly. Another example is the ability to attack with a venomous sting in venomous snakes and scorpions. Snakes use fangs and scorpions use tail stingers, but they both do the same thing: subdue prey and allow animals to defend themselves if needed. In Africa, several genetic variants of the enhancer genes that make lifelong lactose digestion emerged as early as 3,000 to 7,000 years ago. These mutations were especially favorable among ethnic groups that followed a way of life which put them in close contact with animals that produce milk. These people were pastoralists. Pastoralists are groups of people that make a living herding livestock such as goats, cattle, camels, and yaks. As herders, they move their animals from one pasture to the next, depending on the season, and also to avoid overgrazing. The milk produced by these animals constituted a significant part of their diets, so naturally, those who could tolerate dairy well were more likely to survive in this way of life. They depended on the livestock to get fur to cover their bodies, transportation for themselves and their goods, meat, and last but not least, milk. Lactase persistence is common in the modern day, specifically among descendants of pastoralists, many of whom still follow the same lifestyle that their ancestors followed thousands of years ago. Pastoral culture in Africa is heavily represented in East Africa with the Beja, Ethiopians, Maasai, Kenyans, Oromo, Somali, and Tanzanians being great examples. The Beja pastoralists from Sudan have a very high prevalence of lactase persistence at 88%. So it actually turns out that the stereotype that Black people across the board are lactose intolerant is actually false. Many Black people are genetically lactose tolerant. And of course, many Black people also are not. And when you reflect on the vast size of the African continent and the many diverse cultures and ethnic groups that call it home, the fact that there is such a variation in genetics there really isn't all that surprising. Now, of course, herding and managing cattle didn't only happen in Europe and in Africa. So you might be wondering, what does the distribution of lactose tolerance look like across the globe? Now, on this map, you can actually see how lactose tolerance is distributed across the globe. And you can see the key here to the right. Blue means that there is a high concentration of people who tolerate lactose well based on research that was done in that part of the world, and red means the opposite. Anyways, it comes as no surprise that most of the blue dots are in Europe. Ireland, the UK, Norway, Denmark, Sweden, and so forth have a high prevalence of lactose tolerance. Africa is mostly filled with red dots, so there's a lot of lactose intolerance there, but you will notice that there's a bit of blue there as well, which, as we just discussed, is likely coming from people who descended from pastoralists. Over in the Middle East, Kuwait and Saudi Arabia have intermediate levels of lactose tolerance. Interestingly, the southern part of Europe going into the Mediterranean does not have much lactose tolerance, but I'll talk more about that later. Eastern Europe and Asia have low to moderate levels of lactose tolerance. Mexico has a pale blue dot, so they're in the middle but lean slightly towards lactose tolerance. I would suppose that has something to do with many Mexicans being mixed with some Spanish heritage, since Spain is one of the European countries with a high prevalence of lactose tolerance. That theory doesn't really hold though, because other Latin American countries on this map that also have significant quantities of people with European heritage, Colombia, Chile, Uruguay, Brazil, have red dots. This may have more to do with who is being sampled in these countries. Interestingly, New Zealand has a pale blue dot, while Australia has a pale red dot, indicating that they're both in the middle when it comes to the amount of people there who can easily tolerate lactose. My suspicion is that this has a lot to do with how mixed their demographics are, with people of Maori, Asian, and European descent. New Zealand is about 70% European, while Australia is 60 to 70% European. The United States is showing as a pale red, but using a single dot to represent a racially and ethnically diverse country that has had many waves of immigration is like reading one chapter of a novel and thinking that you understand it all. Based on research, we know that about 83 to 93% of Caucasian Americans who can trace their ancestry back to Europe or Scandinavian countries have lactose tolerance, while people of Mexican heritage are at around 30% and African Americans are at around 12 to 40%. Unfortunately, I'm not seeing any data for the Caribbean. That's too bad. So now, why is it that some cultures around the world developed lactose tolerance and others did not? Why didn't all of us, European, African, South American, Asian, people from all over the world, evolve the ability to be able to enjoy something as readily available as dairy as much as we want past childhood? The answer to this question has to do with the history of the coexistence of humans and livestock. Nowadays, we're used to having access to milk, cheese, and yogurt in the grocery store as dietary staples. So most of us, outside of farmers, don't really spend much time thinking about how milk is acquired. The main type of milk that we drink here in the US comes from cows. But those cows didn't just start lining up out of the blue for us to milk them. Those cows, known by the scientific name Bos taurus, are the descendants of the wild bovine Bos primigenius, commonly known as the aurochs. The aurochs was much larger than the modern cow and had impressive horns. It roamed across East Asia, India, Africa, and Europe during the Pleistocene. Over in India, the domestication of the aurochs led to the modern zebu, Bos indicus. The aurochs went extinct in the early 1600s. Now, there is some debate about where cattle domestication first took place. The most widely accepted theory is that cattle were first domesticated in the Near East, aka the Middle East, and then farmers migrated up north to Europe, down south to Africa, and then east to India and China, and spread cattle herding that way, which became critical for the flourishing of these societies given the many uses of cattle. Like I said earlier, beyond providing milk, they provide meat, hides, transportation, and even a source of labor. However, recent scientific evidence points to there being possibly at least 4 places on Earth where people started to domesticate cattle roughly around the same time. So we have 10,500 years ago in Anatolia, a historical region which spans the majority of modern-day Turkey, 10,660 years ago in northern China, 10,000 years ago in Northeast Africa, specifically Sudan, and 8,000 years ago in the Indus Valley, a historical region which overlaps with parts of India, Pakistan, and Afghanistan. It is possible that cattle domestication started in multiple places and was spread by people originating from the Middle East who probably were further along in the domestication process and so were able to spread their breed of cattle more successfully, and that breed became more dominant over local breeds across time. In any case, what we can agree on is the fact that cattle were one of the first dairying animals to be domesticated by humans. Goats and sheep were also domesticated around the same time as cattle. Then came the domestication of dairy buffalo in the Indus Valley and yaks in Tibet around 4,500 years ago. Camels were domesticated between 3,000 and 5,000 years ago. In populations where livestock domestication was common and consumption of dairy and dairy products was high, people who could tolerate lactose well into adulthood were at a genetic advantage. This is actually the premise of what is called the cultural historical hypothesis. Another theory for why lactose tolerance may have become more prominent in certain societies is that the ability to tolerate lactose may have been of critical importance during specific time frames when there was scarcity and rampant disease. Milk is a reliable source of nutrients, including carbohydrates, protein, and calcium. It's also hydrating since it's over 90% water. This would have been of particular importance for populations of people living in very dry environments, such as some parts of Africa and the Middle East. This theory does kind of overlap with the first one. The third and final theory is that people evolved to be able to drink milk into adulthood so that they could get more calcium into their bodies. Lactose in milk actually helps to boost the absorption of calcium, an essential mineral for bone health. Having a source of calcium with a built-in absorption enhancer may have been advantageous, especially for people living at high latitudes who were not getting as much vitamin D from the sun as people living near the equator. Remember that vitamin D is crucial for calcium absorption, so having the extra calcium plus lactose may have really made a difference for those populations of people whose calcium absorption may have already been lower due to them having less sun exposure and thus producing less vitamin D. This theory is controversial, however, especially because the overall magnitude of the effects of lactose on calcium absorption isn't that large in adults. The cultural historical hypothesis is really the strongest and most probable theory, especially because the frequency of lactase persistence or lactose tolerance correlates really well with societies who have a history of herding or pastoralism. So in essence, lactose tolerance evolved due to random mutations and became more common in populations where that mutation was beneficial, which would be those that were living in harmony with livestock. However, history actually didn't really play out that way for all cultures that were living in harmony with livestock. The cultural historical hypothesis completely falls apart when you look at pastoralists in Asia. Like I said at the start of this video, people of Asian descent tend to be lactose intolerant. Yet, there is actually a long history of livestock domestication and pastoralism in Asia. In Central Asia and Mongolia, mare milk has been consumed for at least 5,500 years. Despite this fact, herders from Mongolia and Kazakhstan have a low prevalence of lactase persistence or lactose tolerance at 12% and 24 to 30% respectively. Nowhere near the 90% prevalence that you see in Scandinavia or among the Beja pastoralists of Sudan. Even up to the present day, an estimated 40% of Mongolians continue to live a nomadic lifestyle. So what gives? One potential explanation is that there just wasn't enough social isolation in this part of the world for natural selection to do its thing. Central Asia is a region that sees frequent migration and is surrounded by non-pastoral groups of people. If the local herder population was mixing and making kids with the neighboring non-herders, then the chances of the lactase persistence genes becoming more and more prevalent would have been slimmer. And actually, Asian herders are not the only group of people who have a low prevalence of lactose tolerance despite a long history of dairy farming. The Sami, a group of people who are indigenous to the northern regions of Norway, Sweden, Finland, and Russia, have been hunting and herding reindeer for thousands of years. Yet, they have a much lower prevalence of lactose tolerance relative to the broader Scandinavian population. The Middle East is a bit of a mystery too. It is in this part of the world, in the Fertile Crescent, where agriculture and animal domestication are believed to have emerged for the first time in human history, over 10,000 years ago. Yet, as I mentioned earlier when we were looking at the world map, people in that region of the world only have a moderate level of lactose tolerance, around 40%. Fortunately, there are some possible explanations for these paradoxes. In the case of the Sami, reindeer were domesticated way after cows were, about 2,500 years ago versus 10,500 years ago. That 8,000 year gap means that humans have had way more time to co-evolve with cows than they have with reindeer. Furthermore, reindeer milk actually has less lactose than cow milk, meaning that the need to develop lactose tolerance just isn't as great if you're relying on reindeer milk. As for people living in the Middle East or Mediterranean part of the world, their moderate levels of lactose tolerance may be explained by the fact that they tend to consume dairy in a way where it's transformed into a product that has a lot less lactose, therefore making it easier to digest that product even if you don't have the genes for lactose tolerance. Yogurt is derived from fermented milk, and during that fermentation process, bacteria break down some of the lactose in the milk, leaving us with a product that has less lactose than just plain regular milk. Likewise, a single serving of cheese generally has less lactose than a single serving of milk. Some types of cheese, especially hard aged cheeses like Parmesan, have virtually no lactose because the bacteria involved in the production process have more time to break down the naturally occurring lactose. Other dairy products like butter and cream, which are mostly fat, contain just trace amounts of lactose. And we actually have data to back up this theory as well. In the Mediterranean and Middle East, people consume less fresh milk, around 102 liters per person per year, and more cheese when compared to people in Northern and Central Europe, where fresh milk is enjoyed at comparably higher rates, 489 liters per person per year, and less of that milk gets turned into cheese. Now, this variation in how dairy and dairy products gets consumed in different parts of the world may just have to do with cultural preferences, but it may also have to do with what is often called the mother of all inventions, which is necessity. In warmer climates, the need to convert milk into a product that could last for months or years may have been a driver for the favoring of dairy products over plain fresh milk in the Mediterranean and Middle East. In fact, it is believed that yogurt was discovered way back when animal skins were used to transport milk across vast dry lands, and the bacteria present in those bags caused the milk to coagulate into yogurt. Now, to summarize, high levels of lactose tolerance by and large are most prevalent among ethnic groups where the consumption of high lactose milk was the norm for several millennia. Moderate levels of lactose tolerance are more common among populations where milk was also consumed for several millennia, but had a higher fraction of it that was fermented into lower lactose dairy products. And low levels of lactose tolerance can be explained, at least in part, by lack of an ancestral dairying culture, a relatively recent dairying culture, or frequent mixing with non-dairying ethnic groups. So now, what are you supposed to do if your ancestors were not European agro-pastoralists or African herders and you are unfortunately lactose intolerant? Well, the first thing that you should do is stop worrying, because lactose intolerance is actually kind of overblown. Let me explain. First of all, I am not trying to downplay the very real side effects of lactose intolerance. If you have ever been out in public and had to desperately search for the nearest restroom because you consumed a little bit more dairy than you had planned to, please know that I am not making light of your struggle. The point that I'm trying to make is that even with lactose intolerance, many people still can consume dairy products without any of the awful side effects. And I'll explain how right now. If you are lactose intolerant, you just need to be mindful of 3 key things: the amount of dairy you have in one sitting, how often you consume dairy, and what you have that dairy with. Okay, now let's talk volume, the amount that you have in one sitting. There's data which shows that 12 to 15 grams of lactose can be tolerated well in people with lactose intolerance. For reference, 1 cup of regular cow's milk has around 12 grams of lactose. Spacing out your intake of dairy products can also help. So instead of having a cheese quesadilla with a milkshake at lunch, you can try having the quesadilla at lunch and then the milkshake at dinner. Combining dairy with other foods can have the effect of slowing down its digestion such that your intestines are getting a smaller dose of lactose at any given time, which can make it easier for you to break it down with minimal, if any, side effects. Lactose-free dairy products can be a great option too. Brands like Lactaid provide milk that has been exposed to lactase enzyme, so the sugar is basically pre-digested for you. You can also buy the lactase enzyme separately and have it with your meals. Now, I'm going to say something important. These management techniques apply to lactose intolerance, not to a milk protein allergy. Lactose intolerance is restricted to your gastrointestinal system and can cause gas, bloating, diarrhea, etc., while a milk protein allergy can trigger a full-on immune response that can be life-threatening. And also remember too that this video is just for informational purposes. You should always talk to your healthcare team about what is best for you. So if you are lactose intolerant, just know that not all hope is lost. You can still consume dairy products without the awful consequences once you keep these tips in mind. And if you make the mistake of getting too enthusiastic with your dairy intake, well, your body will let you know and you can adjust from there. What's interesting though is that the way how a person's body might respond to lactose intolerance isn't always the same. Have you ever noticed how some people who are lactose intolerant will say that they can't have too much cheese because if they do, they'll get diarrhea? Whereas other people might say, I can't consume too much cheese because if I do, I'll end up not being able to go to the bathroom. They'll have constipation. This difference in how people's bodies respond to lactose intolerance actually has to do with the gut microbiome. I used to make this joke a lot, especially in my older videos, about how sooner or later I always end up having to talk about the gut microbiome, and that's because it's true. You could say that all roads lead to the gut microbiome because it plays so many critical roles in so many aspects of your health. But staying on topic, it is that unique combination of microorganisms that you have in your gut that determines the way that your body responds to what you eat. In people with lactose intolerance, lactose sugar does not get broken down in the small intestine, so it continues down the tube to the large intestine. Here, gut bacteria will break down the lactose sugar in their own way via fermentation. But here's the thing. Not all people with lactose intolerance have bacteria that are good at fermenting lactose. In those people, the sudden rush of lactose into the large intestine causes a shock to the system. It's called osmotic shock, where lots of liquid gets pulled into the colon and they end up with diarrhea. In contrast, in people whose gut bacteria have become pretty good at breaking down lactose, those bacteria produce a lot of gas in the form of carbon dioxide and methane, which can lead to constipation. And this is the case for about 30% of people with lactose intolerance. Here's what's nice though. You can, in a sense, kind of train your gut to tolerate lactose better. And this is because the gut microbiome is not static. It responds to what we eat every single day. So consuming just small amounts of lactose or even using probiotics could be beneficial for some people. But now the question is, why should you bother with dairy anyway? Why risk it? Well, aside from the obvious advantage of being able to enjoy pizza, quesadillas, lasagna, ice cream, milkshakes, parfaits, and other delicious dairy products, consuming dairy products can be beneficial for your long-term health because of their specific nutritional benefits. For one, dairy products are generally an excellent source of protein and calcium. Now, if you don't prefer dairy, that's okay. Protein can be found in many other foods such as chicken, beef, fish, and beans. You can also get lots of calcium by consuming foods and beverages fortified with calcium, such as orange juice and soy milk, foods processed with calcium, such as tofu made with calcium sulfate, and even canned fish if you get the ones with bones in them, like sardine and salmon. Vegetables like spinach, kale, cabbage, and broccoli provide some calcium, but not as much as the options I listed first. So if you choose not to consume dairy, you're going to want to pay very close attention to your calcium intake. As I mentioned before, dairy products can also be fermented into products that are very beneficial for your gut health. For example, yogurt and kefir, however you pronounce it. If you prefer not to partake in dairy, you can also get beneficial probiotics from other fermented foods like sauerkraut, kimchi, and kombucha. Well, that's it for today. If you enjoyed the video, do not forget to give it a thumbs up and leave a comment. And if you feel like someone you care about could benefit from the information presented in this video, go ahead and share the video. All right, take care.